All right. Okay. If f of x and g of x are inverses of each other, it means for every point AB on the graph of f of x, there is a corresponding point BA on the graph of g of x. So if 1, 7 is on f of x, 7, 1 is on g of x. So if we have functions f of x and g of x, and we know they are inverses, and they have given us a table, and I've got the point 2, 5, 4, negative 2, 6, negative 4, 9, 0, 10, 1, then if I'm asked for points on the inverse, here's all I've got to do. Flip them. 5, 2, negative 2, 4, negative 4, 6, 0, 9, 1, 10. No, we cannot. We cannot. All right, so if f of x and g of x are inverses, then the graph of f of x can be reflected over the line y equals x to produce the graph of g of x. This is all stuff we are like reviewing from pre-cal, so it's not actually even the calculus part of it yet. We will get to it in part B and C of these notes, but we're just kind of reviewing on inverses. So like for example, right here, this red graph right here has the point 3, negative 2, which means what point should be on the other graph? Negative 2, 3, and right there's the corresponding point that goes with it, negative 2. And you could do that with any point on the graph. That would be the case there. So, if 3, 4 is on the graph of f, name a point on the graph of f inverse of x.
4, 3.
4, 3. Okay. Example 3. We are given the graph of f of x below. List 4 points that are on the graph of f inverse of x.
1, 3.
All right, so
3, 3, 1.
okay, so right here is 1, 3, which means 3, 1 would be a point. What's another one?
3, 5.
3. No, that's backwards. Hold on. So 5, 5, 3 right here, right? Means that 3, 5 would be on the inverse. How about some over here with some negative values?
0, negative 2.
Okay, so we got the point right here, which is negative 2, 0. That would be 0, negative 2 on our graph of f inverse. All right, another one. 3, negative 5. So we got here 5, negative 3, if it'll let me write. It's been hateful. So negative 3. No, I got my signs wrong on that. Negative 5, 3, and over here we want 3, negative 5. Yeah, so like that's particularly helpful. Like if you were asked to graph this, graphing that just by looking at it is hard to do. But you could check points to make sure it was right, like if it was multiple choice or something there. All right, so we know f of 3 equals 5, f of negative 1 equals 3, f of 5 equals negative 1. We are supposed to find f inverse of 3. Okay, so this is a concept like that it's super simple, yet was kind of confusing to me when I was first presented with it. So whenever we have f of 3 equals 5, that means that, like, if we plug a 3 in, F is going to tell us that, oh, if I write the right number, it will help. F tells us that if you plug in a 3, you get a 5. Okay? F inverse is what gets you back to that 3. So, like, whenever I have f of 3 equals 5, f inverse of 5 will equal 3. Right? Because it goes backwards. Whatever was the y right here becomes the x whenever you're talking about the inverse. So f inverse of 3, this piece of information right here does not help us to find f inverse of 3. Okay? If I think about this one, -1 and 3, f tells us that if we plug in -1, we get 3. Well, f inverse is the opposite of that, or the inverse of that. So f inverse of 3 equals -1. Does this help us? Is this what we're looking for? Yes. We were looking for f inverse of 3. So right there is our answer, -1. This information, so the first piece of information they give you is a distractor. That second piece of information they give you is a distractor because it's telling you 5 goes to -1. So if we go backwards, f inverse of -1 equals 5. So that doesn't help you answer this question either. Okay, so what was the y on the original is going to be the x on the problem. Okay, so let's look at it with a table. The table gives you more options here, even more than the one before. If we're given this table, we're supposed to find f inverse of 4. Anybody know what it's going to be? They put several 4s in here. I'm pretty sure 3 1's not going to help us any. What do you guys think? So let's think of writing this in notation. This is 0, so like f of 0 equals 4, right? And right here, this means f of 4 equals 2. And this means f of 7 equals -4. So the inverse, x and y's switch. So f inverse of 4 equals 0. F inverse of 2 equals 4. F inverse of -4 equals 7. Which one of those is what we're looking for? The first one right here, we would get 0 as our answer. To do it quickly from the table, if you're doing f inverse of 4, it's your x coordinate right now in the inverse, which means it was the y in the original function, which is what you're looking at. So you're looking at this line, your f of x is your y coordinates, and you're finding 4, and it's going to be the number that goes with that. Does that make sense? Like I said, it's a very simple concept, but to me it was very confusing whenever I first encountered it. All right, so this we have done a lot of in pre-cal. We didn't do so much of that, like finding the inverse value. But to find inverses by hand, you switch the x and y, solve for the new y, replace the new y with f inverse of x. So, like, for example, that f of x right there is like our y. We would switch our x and y, so we would have x equals y minus 3 cubed minus 5. And now we want to solve for this new y right here. Okay, to do that, what would I do? I need a cube root, but it's not the first thing I'm going to do. I got to get rid of this 5 first. So I'm going to add that 5. And so I'll get x plus 5 equals y minus 3 cubed. And then I will do the cube root. So I will get the cube root of x plus 5 equals y minus 3. Last thing, add the 3. Now, I would probably write it like this, 3 plus the cube root of x plus 5 as my inverse, so f inverse of x equals 3 plus the cube root of x plus 5. But you do, you can write that 3 on the end. Just be careful, because if you draw your line for your cube root too long, it would be incorrect because it's not underneath the cube root. All right. Do you guys remember doing this? That should hopefully be something that maybe you need a little brushing up on, but you remember seeing it. All right. Inverses of these types of problems. All right. So for this, you got to switch your x and y's. So you're going to have y equals 2. I'm sorry. No. You're going to have x equals 2y plus 5 over y minus 4. You need to solve for the y, but you can't do that when it's in the denominator. So you are going to multiply this side by y minus 4, as long as you also multiply this side by y minus 4. And that will give you x times y minus 4 equals 2y plus 5. Now, you have two y's there. It is going to be very difficult to put them together. Because we are short on time, I'm just, instead of having you guess on this for a little while, we did do some of these in pre-calc, but it's been a long time. These are very similar to implicit differentiation problems. They are not implicit differentiation problems, but they're very similar because you can use the same strategy to solve for that y. So if you distribute that x, you have xy minus 4x equals 2y plus 5. You can move everything with a y to the left side and everything with an x to the right side. Now what could we do? Factor out that y. And then just divide by our x minus 2. So f inverse of x here, was it an f? Yeah. Is going to be 4x plus 5 over x minus 2. Okay. Questions? Let's see. We need to get to our quiz. Let's see here. I may just do that at the beginning of class tomorrow. So let me look at this assignment here.